In this lesson, we'll look at the components and controls that are used in the generation of emergency power. When you are in an emergency situation, you'll see many warnings displayed on the electrical power panel, but not on the ECAM displays. These displays are lost, as electrical power is only supplied to essential equipment. At times, as shown here, we'll freeze the screens so that you can see them before the emergency systems automatically start to supply electrical power. In a real-life situation, however, power would be supplied almost immediately. As you work through the topics, remember that it's the components and controls that we're interested in here, and not the emergency warnings and procedures. These will be covered later in the lesson. Emergency power is achieved by either a static inverter, INV, which converts DC essential power to AC power, or by a standby generator, which, under certain conditions, automatically supplies both the AC and DC essential buses and the AC emergency bus. We'll also look at the electrical power panel controls. These include a battery override push button, which allows you to force the connection of the batteries to the DC part of the network if the automatic switching fails, and a land recovery push button, which is used during landing to restore power to equipment which was isolated due to failure of the normal power generation system. We begin in flight, where both your engine generators have faults and your APU is not running. Take a little time to think about how power may be restored. When you're ready, select the forward icon. Initially, when the normal generators are lost or unavailable, the batteries automatically start to supply the DC essential bus. The static inverter will convert this DC power to AC power and supply the AC emergency bus. You'll notice from the electrical power panel that both the DC essential on battery and the AC emergency on inverter lights come on when supplied by the batteries. As the life of the batteries dictates the time this power is available, it's necessary for a backup system to be able to take over. Under certain conditions, which are covered in the next topic, a standby gen can take over from the batteries and supply emergency power for the AC and DC parts of the network. A standby generator is available to supply emergency power. When running, it's driven at a constant speed by a hydraulic motor, which is powered by the green hydraulic system. This emergency power supply also has a generator control unit, GCU, which provides AC voltage and frequency regulation, as well as protection against undervoltage and underfrequency faults. The standby gen will start automatically in flight when the DC normal bus supply is lost, Gen 2 is unavailable, the DC essential bus is automatically supplied by the batteries and not because the battery override push button is on, and green hydraulic power is available. Once the standby gen has stabilized and no faults have been detected by the GCU, it will supply a part of the AC essential bus, the AC emergency bus, and the DC essential bus. Note that the batteries have disconnected and the local warnings on the electrical power panel have also gone out. Although one of the starting conditions has been lost, the standby gen continues to run. Let's return to the point where the batteries were supplying the network and see what happens if the standby gen fails to start automatically. To overcome this problem, press the Standby Gen push button. This push button does not control the automatic start of the Standby Gen, but forces it to run if the battery override push button is off and green hydraulic power is available. If the Standby Gen is started in flight, it will continue to run after landing. If, however, the Standby Gen is forced to run on the ground, its operation is limited to 2 minutes. Green hydraulic system and DC power must be available. If a fault occurs with the normal power generation and the BCC will not allow the batteries to supply emergency power, the battery override push button may be pressed to force the connection of the batteries to the DC essential bus and, through the static inverter, the AC emergency bus. Before you do this, however, you can attempt to start the APU and recover the entire electrical network using the APU Gen. You may review the starting limitations for the APU in the APU Warnings and Operating Limitations lesson. If the APU will not start because of icing or altitude limitations, you must connect the batteries. Do this now. With the battery override push button selected to on, the electrical power panel displays the DC Essential on battery and AC Emergency on inverter lights to confirm the connection of the batteries to the AC and DC parts of the electrical network. When both engine generators and the APU Gen have failed or are unavailable, the Standby Gen takes over. As the DC normal bus is no longer powered, some flight controls and braking equipment are lost or their performance is degraded. These items, like the flaps, slats and spoilers for example, may be recovered by selecting the Land Recovery push button to on. They are then connected to the DC essential bus. For more information, refer to the electrical sections 304 and 305 in the QRH. Note that the items of interest are marked with an asterisk.